Khaled, you're on mute.
Oh, wow. Okay, I'm sorry. Hello, everyone, and welcome to a new and special episode of the Tech Cafe podcast. My name is Khaled Nagar, and I will be co-hosting today's episode with my friend Ahmed Musbah. Please allow me to welcome our esteemed guest speaker, Valentina 𝗘𝘅𝗶𝗁, who will talk to us today about test-driven development in hexagonal and clean architecture. Welcome, Valentina. We're glad to have you with us today.
Thanks a lot. I'm really
Please
excited to
allow
be
me to
here.
welcome. Thank you, Valentina. Let me start by presenting Tech Cafe. Tech Cafe is a startup company dedicated to empowering the tech community and enabling creativity and innovation in the tech industry. We offer this technical podcast and two professional services, technical workshops and consulting. Tech Cafe podcast has aired many technical episodes this year, and we have hosted many great guest speakers. We have also sponsored this year's DevOps Days Cairo conference, and we have community partners, and we were community partners in this year's Startups Without Borders Demo Day. Visit our website to learn more about our services. I leave the mic now to Ahmed Musbah to introduce our today's sponsor.
Thank you very much, Khaled, and a warm welcome to our attendees and to our guest speaker, Valentina 𝗘𝘅𝗶𝗁. A huge shout out to our sponsor, Cegedim Egypt. Cegedim is a global technology and services company committed to innovation. It supplies services, technological tools, specialized software, data flow management services that are targeted notably at healthcare professionals, healthcare industries, and life science companies. Since 2018, they have established a dedicated development center in Cairo. The teams in Cairo contribute in products development for a wide range of healthcare products across different regions, including France, UK, Belgium, Spain, and Romania. To know more about Cegedim Egypt, you can explore their activities and updates on their LinkedIn page. And you can follow their LinkedIn page by simply scanning the QR in front of you right now. So a big thank you to Cegedim Egypt for sponsoring today's episode. So without further ado, I leave the mic to Valentina to talk to us today about TDD and hexagonal and clean architecture. So Valentina, the mic is all yours.
Thank you very much. So we could start with the presentation. If you could maybe bring it up. Thank you. So TDD in hexagonal architecture and clean architecture. So this is going to be an interesting topic because we're combining, I guess, multiple topics. First of all, a short introduction about myself. I'm a technical coach and I help development teams to increase software development quality using test-driven development and clean architecture. And I've written quite a number of articles on these topics. So feel free to connect with me on LinkedIn, Twitter, and you can also have a look at some code samples on my GitHub as well. So for today, we will firstly be looking at what is test-driven development, essentially what's the essence regarding behavior. And then we will look at both hexagonal architecture and clean architecture and how the kind of tests that we write with TDD is affected or not affected by the choice of architecture. And finally, a practical code demo. So first of all, the foundations of test-driven development. So coupling tests to behavior and not to structure. I think that this is an important point because sometimes people think that BDD, behavior-driven development, is with behavior and that test-driven development is not. But let's see. So from Kent Beck, who wrote TDD by example. So there are multiple points where he simply emphasizes the essence that tests should be coupled to behavior rather than structure. So tests should be coupled to the behavior of code and decoupled from the structure of code. So this is an important point. So tests should express behavioral concerns and they should not express structural concerns. And we will discover that what that means as we go along in this session. And again, similar thing, programmer tests should be sensitive to behavior changes and insensitive to structure changes. So this means if certain behavioral changes are required, then it is fine for our tests to be modified in accordance with that. But if only the structure changes, but not the behavior, then our tests should remain stable. And lastly, if the program's behavior is stable from an observer's perspective, no tests should change. This is yet another important point about understanding behavior. So this is behavior from some observer. So it is related to functional changes. We could think about it. Examples of behavioral changes are if a QA engineer was inspecting the behavior of our program now, and after a change, is there a functional change visible or not? So we can see the words behavior as synonymous to functionality. So the key point is, if behavior remains the same, then and behavior is functionality, then tests themselves should not change in that case. So all of this was about behavior. Now let's jump onto structure. So refactoring is about changing structure. And Martin Fowler said, refactoring is a disciplined technique for restructuring an existing body of code, altering its internal structure without changing its external behavior. And also when we refactor, we change structure but not behavior. So when we combine both of these two slides, we see here that there are essentially two types of changes. There are behavioral changes, which are observable from the outside. So if someone like QA engineer or user or anyone would be able to observe behavioral changes, whereas structural changes are changes which are internal to the program. So when we do an internal change, i.e. a structural change, it is not visible to anyone who is observing or using our program. Now, this was just a very short introduction. If you aren't yet familiar with it, these differences regarding behavior and structure, I highly recommend looking at some of my previous meetups to get better foundational understanding. For now on, we will now jump onto the next topics, hexagonal architecture and clean architecture, and see the connection with the test types, especially unit tests that are done with TDD. So hexagonal architecture, it's about isolating the application that we're making from external technologies. So what's the motivation behind hexagonal architecture? From Alistair Cockburn, create your application to work without either a UI or a database, so you can run automated regression tests against the application, work when the database becomes unavailable, and link applications together without any user involvement. So for him, it is important when he uses the word application, he uses it in a different context compared to when most developers say the word application. So if you're a Java developer, you may use the word Spring application. If you're a .NET developer, you may say ASP.NET application or something. He is using the word application in a different context. When he says application, we could synonymously say he is referring to the domain. So it is something that is independent of REST API, UI, database, and external systems. It's the core. It's the essence of what we're making. It's the domain. And the key point is that that application should be able to run without the presentation layer, the UI, nor the database, so that we can run it in isolation and that we can test it in isolation. And the second point, allow an application to be equally driven by users, programs, automated test or batch scripts, and to be developed and tested in isolation from its eventual runtime devices and databases. So this means when he is looking at this application, and we can think of it as the domain, that we can we can call it whether by front end or automated tests or maybe console scripts or anything, that it should not really matter who is calling it. And in this way, we are achieving its isolation. And let's look at diagrammatic representation. So this inner green hexagon, which is, he calls it application. Some may call it application core. I like the word application core to not get confused with the word application for most developers, though in his original writings it is written application, and it is synonymous to the word hexagon. That essentially reflects the domain that we're modeling, and that's independent of UI, independent of the REST API, and independent of databases. Now, when we look at the left-hand side, we have these primary actors. So these people, they could be users, programs, or scripts. So anything that is going to call our application. Typically, in practice, you may have human users who may need to use the application, or you could have front-end apps that need to use the application, or tests. Now, since they can't just directly call the application core, here we have these user-side adapters. So common examples of user-side adapters or driving adapters, examples include GUI, console, REST API, tests. So that is all on the left-hand side. And they call user-side ports or driver ports. So these driver ports represent entry points to the hexagon. So as we can see, they can't directly access anything within the hexagon. They can only access it through these very specific entry points. So you can think of these entry points as like maybe doors or windows to a house. So little openings that we can, enter. Or similarly, when you go to a bank, you can't just walk into the back office and say, hey, I would like to have a loan, but instead you have to go to the people to the front desk, hand over your request. They will communicate and do stuff in the back office and tell you a response. So you can think of user-side ports or driver ports similar as the front desk when you go into a bank or any other company. Whereas everything that is inside the hexagon, that's where all the business logic and all the little details are occurring. You can think of that as an analogy in a bank. All of those people behind the scenes, the people in the back office, the ones who know all the business rules and logic regarding credit loan applications. And they are doing some work. So that's where the business logic is. Now, what happens is that sometimes we can't just perform all our business logic ourselves. Sometimes we may need to also have some persistence concerns. So we may need to talk to a database, or we may need to get some data from a third-party system. Maybe we need to get some data about, let's say, products from an ERP. Or maybe we need to send data to a system. So maybe we need to integrate with PayPal and send an order to PayPal. So anything that is external, and in the simplest sense, you can think of it as anything that is I/O. So it could be databases, anything, files, databases, web services. So it could be external REST APIs, external SOAP services, FTP, email, SMS, etc. All of those are on the right-hand side. So they are essentially secondary actors. And what happens is that this application core will not directly talk to some secondary actors. So it will not directly talk to the database or to web services, but instead we could say it will indirectly talk to them. It will talk to them through a server-side or driven port. So this means application core, it is actually unaware of what the persistence mechanism is. So it doesn't know, is it SQL database, is it no SQL database, or is it, let's say, files being used for storage? So this driven port abstracts that away. Similarly, when we're connecting to a third-party system, the driven port does not expose whether we are connecting to an external REST API or SOAP, but only in terms of, how should I say, the business language. So one example of a, how should I say, a driven port, let's say we need to store bank accounts somewhere. So there could be a bank account repository with methods to add a bank account or to retrieve a bank account from repository. In that one, when you hear of those methods, you have no idea what kind of database is behind the scenes. Or similarly, maybe when we need to communicate with PayPal, the driven port may just have a method which says, send payment or send invoice or something like that with the payment details. And there's nothing about the PayPal REST API in there. And this is where driven adapters come in. They are the only part that is aware of how exactly to communicate with the driven adapter. So when we're communicating with a database, the driven adapter may have SQL queries or use an ORM or whatever else. And when communicating with external systems, for example, with PayPal, it may have a HTTP client which is going to make a request to PayPal. And this is where we get to the fun part regarding the test types. So the point here is when we have hexagonal architecture and the kind of tests, and I just want to say, so in hexagonal architecture, tests are adapters themselves, just like REST API is an adapter or GUI is an adapter, tests are also adapters. So these tests, as we've seen on the previous part, they are targeting the driver ports. Now, the driven ports in these kind of tests, they are replaced with test doubles. So maybe you may use fakes, or mocks, or stubs, or any other test double. So those are the only kind of tests which are described if you look at hexagonal architecture from Alistair Cockburn. Now, these kind of tests, I put here the word unit tests aside from just tests. So Alistair Cockburn, he just uses the word tests in hexagonal architecture. Here I added the prefix unit tests because they satisfy the characteristics for unit tests, because we are able to test in isolation from I/O. And the other also important point that I want to emphasize here is that these driver ports, they are exposing the use cases of the hexagon. So examples are, if we are making a banking system, these use cases might be to open a bank account, to withdraw funds, and to deposit funds, and maybe also suspend the bank account. So that's it. You know, we would only have ports corresponding to those use cases. Here inside the hexagon, we could have all complex calculation, etc., and all of those details, but the driver ports are exposing the use cases only. And then as we zoom in further into tests and use case implementation, the key point here is that when we write these tests, they are targeting the driver ports. So we can think of these, driving ports. We can think of it as an interface to the hexagon. And somewhere inside the hexagon is the implementation of those driver ports. So that's the span of these tests. And furthermore, we also have test doubles, which are substituted here for the driven ports. And the question is, what happens when we refactor? So these kind of tests in hexagonal architecture, which I'm referring to as use case unit tests because they are targeting the driver ports, which expose use cases. These are coupled to the essentially behavior, the API of the hexagon, and they are not coupled to the hexagon. So when we look at these tests, if you look at, again, 𝗘𝘅𝗶𝗶𝗴 material, the tests are strictly going to the driver ports. They are not going inside the hexagon at all. So what that means is that these tests are coupled to the behavior of the hexagon, but they are not coupled to the structure of the hexagon. So they have no idea of the internals of the hexagon. And this has a really important implication. It means that we can do whatever we want inside the hexagon and the tests remain the same. So as long as this API is unchanged, like the behavior, and this also outgoing API or remains stable, we can do whatever we want in the hexagon and these tests remain stable. So we have robust tests. The question is, this whole time we talked about the external system and its interaction through this, interface through the driving ports, as well as the outgoing interface, the driven ports. But we didn't really talk about what's inside the hexagon. From the perspective of hexagonal architecture, the internal of the hexagon is a black box. It is completely up to you to structure the inside of the hexagon in whatever way you like. So this means your choice of paradigm, whether you choose object-oriented, functional, procedural, whether you're going to have a big ball of mud or domain-driven design, you can have anything. You can have clean code, unclean code, whatever you wish to have inside. The thing is that since that is not specified by hexagonal architecture, so it is actually left as freedom for you to choose what you want to do inside, and the tests are only coupled to the tests only have awareness of the API, This means that we can also safely change the structure inside the hexagon, and these tests will remain stable. So if we view these entry points as use cases and the hexagon itself as modeling the domain, it means we can restructure how we're modeling the domain without breaking the tests. And that even includes going from anemic to rich domain, or changing how we model our entities without breaking these use case tests. And here a more precise quote. So ports and adapters. Pattern says nothing about the structure of the inside of the hexagon. You can have layers, you can have components by feature, you can have spaghetti code, you can have a big ball of mud, you can apply TDD tactical patterns, you can have a single CRUD. It's up to you. So this is just further emphasis regarding the key aspect that the inside of the hexagon is not specified. So I emphasize this because one of the biggest misconceptions about hexagonal architecture is when people say, oh, what are the layers inside the hexagon? Well, that's not prescribed at all. So I highly recommend that you look at the material from Juan Manuel, and he's also co-authoring a book with Alistair Cockburn. So I highly recommend his materials for understanding of hexagonal architecture. Now we so since we covered the basics of hexagonal architecture, let's now go on to clean architecture, which I see essentially as a derivative of hexagonal architecture. It takes hexagonal architecture at the foundation, but then has some additional constraints on top. So it is not something completely new. We are just building additional constraints on top. Now, before we go into hexagonal architecture, let's firstly look at the simple case of, let's say, structuring the internal of our hexagon using CRUD. So this means, for example, you have anemic entities. Let's say you have a bank account or order, and all your fields are public, just getters and setters. You've got no business logic inside entities. And all the business logic is implemented only by essentially the implementation of the driving ports. That's fine from the perspective of hexagonal architecture, and maybe we may even start that way. So we're not using any TDD here. And we write these tests, and they are targeting the driving ports. Now, what happens is, suppose that instead of having CRUD inside, we would like to have, use clean architecture. Now, in clean architecture, Uncle Bob specifies that we're going to have entities, and that we're going to have both use cases and entities. So this means somewhere here inside the hexagon, we're going to have both use case implementation and entity implementation, and that those entities, they should be rich entities, that the entities reflect behavior. And here we can choose to apply domain-driven design tactical patterns. And this is fine. When we look at the tests, the tests remain robust because they are coupled only to the ports, so there's no need to change the tests at all. And now let us go to the code demo. So I just want to say these are the GitHub projects. Today I will illustrate mainly the Java example, but you can also have a look at the .NET example. So maybe now we can switch to screen sharing for the code. Okay, great. So I hope that everyone can see the font. If not, feel free to comment. So when we look at this structure, important thing is we have the core. So this reflects the application core, and we have adapters. So it could be either driving adapters or driven adapters. Let's zoom into the core for now. So how to structure the core? We have ports, so we can have the driver, or it's now called driving ports, and we have which are on the left-hand side, and we also have driven ports, which are on the right-hand side. So I'd like to start from the left-hand side, the driver ports. Let's say we have open account. So we have an open account request, whereby to open account we need your national ID number, your first name, last name, and the starting balance. So that is input to the use case for opening an account. And we also have a response. So we have the account number. I just want to emphasize here, I've chosen to use Lombok. This is completely up to you whether or not you use Lombok. Hexagonal architecture does not prescribe whether to use it or not. Here I'm also happen to be using the command pattern for the driving ports. That is one possibility how you can implement driving ports, but you also could have used services as well, so service interface. So you could have had a bank account service interface with a method called open account, and it's got inputs and outputs. So it is up to you. Hexagonal architecture does not prescribe the granularity of your ports. So anyway, we have so this is for modeling one driving port open account. Let's also look for deposit. So when depositing funds, as input, we need to pass in the account number and the amount that we want to deposit. And we're going to, there's no response associated with it. And let's also look at viewing account. So to view some account details, we need the account number, and we will also be getting back details such as the account number, the full name of the customer, the balance, and score. So here in this application, we also have some scoring mechanism regarding bank accounts. And it's also possible that these driving ports will throw some exceptions. So in this case, possibility of validation exception. Again, here it is going to be up to you whether you choose to use exceptions, or you could be returning result objects. Again, it is not prescribed by Hexagonal architecture, so this is just one example. So all of these ports are for the left-hand side, the driving ports. Let's also look at the driven ports. This is when we are communicating, when we need to send outgoing requests. So one example is we need to, let's say, talk to some storage mechanism. So maybe we need to add a bank account. Maybe we need to find an existing bank account by account number, or maybe we need to update a bank account. Now here, I'm using bank account DTO for the very simple reason that Hexagonal architecture itself does not prescribe whether we will be sending rich or anemic versions of entities. So here I'm choosing, let's say, for simplicity case, to go with DTOs here. And we also have a customer gateway. So we're talking to some system or microservice or anything like that, which is able to provide us information for some specific national ID number, is it blacklisted or not? And we're also talking to some non-deterministic sources, such as let's say the system clock. And we're also talking to an external system. So there's some third-party system which provides information about national identity numbers, which we can call, and it tells us, does a national identity number exist or not? Now, when you look at this, for example, national identity gateway and like customer gateway, here you have no idea whether those systems that you are connecting to, are you connecting to external REST APIs or SOAP services or anything. You have no awareness of it. And similarly for storage mechanism, when you look at this, you don't know, are we connecting to a relational database or non-relational database, or maybe to the file system? So it's completely not known. Now that we've looked at both the driver and the driven ports, the question is, well, where exactly is the implementation? I mean, this is just the interface for, let's say, opening an account. Well, where's the implementation of it? And also, what do the tests look like for this use case of opening a bank account? Let's look at the implementation. Here I'm going to illustrate two different possible implementations. I'm illustrating two different possible implementations because hexagonal architecture does not prescribe what the implementation will be inside. So it can be like this, or it can be anything that you choose. Let's first start with a basic CRUD-like implementation of the open account use case. Okay, so here I happen to be using the command handler pattern, though you could have used application services instead. So what happens is, given some incoming request, our use case logic is we firstly do some basic validation regarding national ID number, the first name, last name, and the balance. So here we're checking that, let's say, these ones are not null or white space, and the balance, initial balance, is not negative. We're also going to be calling an external system. So it's some third-party system which provides us information. Does a certain national identity number exist or not? Here we have no idea, is that third-party system REST API or SOAP service or anything else. And we also call another external system. We generate some account identifiers, account number, get the current time, and we construct a bank account object. We store it in a persistence mechanism. So at this point, we don't know, is this bank account being added to a database or file system or anything else. And let's say we also may publish an event about the bank account being opened. And finally, we are returning our response to the caller of this use case. So this is one example of a CRUD-like implementation. So that is one way that you could have code inside the internals of your hexagon. But let's look at some other ways. How would we do it if we were using clean architecture? Okay. Well, in clean architecture, you'll see that the use case code is a lot shorter because certain logic will be moved to rich entities. So here, as before, we are still contacting the external systems. But what is interesting, well, we'll see the bank account. Sorry, I might open up another use case simply to illustrate differences in behavior. For example, notice this part here for deposit funds use case. Bank account dot deposit amount. So this use case is delegating that part of the behavior to the bank account entity. So this is where we have that, you know, structural segmentation of behavior. That some behavior, some logic is in the use case itself, but some logic happens to be encapsulated inside an entity. And then when we open up that entity, the bank account entity, we see, for example, some domain invariants here. And we also see business logic. For example, for depositing, how we are adding to the balance. And when we're withdrawing, that we need to check, is the amount greater than the balance, and then do subtraction. Furthermore, if we decide to apply TDD tactical patterns, aside from having entities, we may also have value objects. So for example, I choose to represent money as a value object. I could also have an anti-corruption layer as well, which does some conversions. So you can look at that when you look at the GitHub code example. And here you can see I'm doing a lot of behavioral, let's say, splitting, for example, for the view account use case. Here I'm delegating to a domain service the score calculator to calculate the score for a bank account. And here we're going to have a series of calculators, for example, calculating scoring for the name. So here you can see a whole heap of business logic and time factors, etc. The main point that I want to illustrate here is that some behavior or like application logic happens to be in the use case itself, like here, and similarly in deposit, like that's the application logic. Whereas some logic, like business logic, happens to be inside domain entities, domain value objects, domain services inside here. So that's it. So you can see here that you essentially have, again, just to compare and to contrast the ones where I wrote a CRUD versus more clean architecture implementation, like that's the open account use case done the CRUD way, and also we're doing it the clean architecture way as well. What happens to the tests? We said before that the tests should not care about internals of the hexagon, but should be coupled only to the ports. So let's illustrate what that means. It means that we can even switch between two competing implementations through refactoring, and the test should not break. So I'm going to open up the open account use case. Here, for all of the driven ports, so, you know, we're connecting to some third-party system for national identity, for customer information, some storage mechanism, system time, etc. Here, we happen to be using fakes. Feel free, you know, you don't have to use fakes. You can use stubs, mocks, whatever you wish. We need some way of getting hold of our use case. Now, notice here, so we have use case, and it is a command handler, which is an interface, accepting our request and returning our response. But here we have no idea what its implementation is. And indeed, what will happen here is I'm going to illustrate that we can choose to use the CRUD version or the clean architecture version of the open account use case. So just a reminder, this is the CRUD version, and this is the clean architecture version of the same use case. So I will be swapping between these, and that we can see that the tests are immune to our switches in implementation. So here we have certain tests, which are unit tests. They fully run in memory, they're fast, independent of I/O. We have a request, we have some expectations. We run the use case and we assert certain expectations about response, and we make also certain expectations against the driven ports. Now here, as we read these tests, there is absolutely no indication whether our use case implementation, whether it is CRUD, whether it is more the clean architecture approach with rich entities, whether in the use case implementation is object-oriented or functional or procedural. We don't really have that. We can't tell. The only thing that we can tell is the interface. So the driver ports and the driven ports. That's the only thing that we know. And indeed, what I'm going to do now is, let's say currently we're going to be using the CRUD implementation of the open account use case. So I'm going to run it. So here our tests are running, and let's see what are going to be the results. Okay, so they all pass. And I'm now going to pretend that we did some refactoring, and instead of a CRUD-like implementation, we're switching to a clean architecture-like implementation, i.e. we are only changing the internals. We are not touching the ports, so the ports remain the same. And let's run the tests again. So, we've done refactoring. So we're switching now to the new different implementation. The tests still continue to pass, so there's nothing red going on. And this is actually the key message behind this whole session, which is when you use hexagonal architecture, you are coupling your tests only to the ports. So the tests will be targeting your driver ports. The tests may also do certain, let's say, assertions or setup or anything against the driven ports, and that's it. That's the beginning and end of your coupling between the tests and the hexagon. So the tests are only coupled to the interface of the hexagon. The tests are not coupled to the internal of the hexagon at all. This means we have full freedom of choice what we will have internally inside the hexagon, whether we will be using a CRUD approach or clean architecture approach or any other approach that you can think of. And when we write tests in that kind of way, then we can even switch between these implementations through refactoring, and the tests remain stable. So that's the main message. Let me see. Could we now maybe share the presentation once more? Okay, great. So what's the key conclusion from this session? So hexagonal architecture helps us develop and test our application in isolation from external technology concerns, so in isolation from UI and database. So here we've seen it as we've looked at those open account, handler, withdraw funds, handler, etc. They have no UI concerns and they've got no database concerns. So the UI will call, or the REST API will call those use case handlers and get their responses, and that's it. And we've seen the isolation from DB. So we do not directly call the DB, but rather we call an interface, which represents an abstraction of a storage mechanism. We've seen writing use case unit tests to help us test system behavior rather than system structure. So the kind of tests that are prescribed by hexagonal architecture, they are targeting the driver ports. So, and those driver ports represent use cases. And those kind of tests, they satisfy characteristics of unit tests because they are fast, they run in memory, independent of I/O. We are able to refactor the system structure within the hexagon. For example, we can refactor from CRUD, so starting with an anemic domain, transitioning over to using TDD tactical patterns, so going from anemic to rich domain, and we can do this without breaking the tests. And this is a key point, that now these tests are robust during refactoring, and that our domain, how we model it, can emerge over time. And I find this to be a very important point, because sometimes when we're starting, maybe it many times is easier to start with an anemic domain, and maybe we can't even see here any rich domain possibilities. And over time, as the behavior gets more complex and complex, we then realize, hey, we would like to apply TDD when that happens, and we are free to do that without breaking the tests. And the benefits are higher, essentially, robustness of these tests and lower maintenance costs, because our tests don't keep on breaking. So this is a really powerful impact, that as we change the model of our domain, but our tests remain stable. So in the end, we essentially end up with a higher return on investment. So I hope you found this useful, and I'm now open to questions.
Thank you very much, Valentina, for this great session. I personally enjoyed it very much, especially the parts where you explained hexagonal architecture. I think that many people who start reading about domain-centric architectures usually jump straight into clean architecture, especially people that are doing mobile software development. And they don't get back to basics, the basic ports and adapter patterns, which basically all domain-centric architectures are built upon. And they tend to lose the benefit of having the flexibility of choosing the kind of design that will be inside the hexagon or inside the application. And I actually prepared something while you were presenting your slides, and I think I'm going to present that. And that is 𝗘𝘅𝗁𝗶𝗶 recently published a screenshot from the book he's currently preparing with Yuan. And the question goes like this in the screenshot: how do I structure the inside of my application? And the answer is simply, this is totally up to you, not my job. So this is really opposed to what you have in Onion and the clean architecture, where in Robert Martin and Palermo, they tell you what to do exactly in your architecture. And since they have mentioned the word domain, I think they're kind of pushing people to go for something like domain-driven design. So thank you very much for quoting Yuan in this part. I liked it very much. And this is just to tell people that ports and adapters are not coupled with domain-driven design. You can still do ports and adapters even if you're not going to be using domain-driven design. So
exactly, and I just want to add there, if we're talking about essence of testability of an application, hexagonal architecture is the essence. Building further on top with additional restrictions, which is what Onion and Clean Architecture do, I see it more as optional. So we may or may not do it. In other words, is it justified or not justified to do a rich domain versus an anemic domain? I view that as more an optional point, and it's based on complexity of the application.
Yeah, totally agree. Okay, let's take one question from the audience. So it reads as follows: what is the difference between a regular driver adapter, example for object storage, for database access, etc., and a gateway driver adapter? Are they not the same? When to use one or the other?
Okay, great. So here, before I answer, I'm assuming here that the word is driven adapter, because all of these is on the right-hand side. So for example, we have driven adapters for object storage, database access, whatever, because our system is calling it. And similarly, those gateways. So for example, in my example, the national ID gateway, which communicates with some third-party systems. From perspective of hexagonal architecture, yes, they are the same. They are all outgoing concerns. And indeed, hexagonal architecture doesn't even prescribe what kind of names to use. The examples that I've chosen to use are simply names which I found personally useful, that for anything which is like storage concern, using like repository to encapsulate object storage, database access, and gateway to mean communicating with third-party systems. But that choice of naming is completely up to you. So to answer this question, yes, they are essentially belonging to the same group from perspective of hexagonal architecture.
That's great. And we have another question from Gabriel, which says, what are the steps to implement a new use case following TDD with clean architecture and red-green refactor approach? I think that's similar to a question I was about to ask regarding practicing London or Chicago school in hexagonal or clean architecture. So maybe when answering this question, we can talk about practicing both schools. Yeah, so go ahead.
Exactly, and indeed, I would extend the question to even start with answering from hexagonal architecture perspective, and then I will go into clean architecture and both of those schools. So I'm firstly going to start explaining using TDD and hexagonal architecture, which is what I view as foundational. So what that would mean is, let's say we have a new use case, and let's say that use case has some behavior. So for example, when we are withdrawing funds, maybe the basic behavior is when we specify a valid amount to withdraw, i.e. something bigger than our balance, that then the resulting state will be that certain amount was subtracted. So that could be, I guess, the main point of the use case. That use case may also have certain details, such as validation errors. Like if the amount is greater than the balance, then the behavior of the use case is to, let's say, throw an exception. Notice in all of these things, when I'm talking about use case, I'm talking strictly about behavior. Here, I didn't say whether you're going to have rich domain or anemic domain, or how you will, or whether it's going to be object-oriented or functional. I'm just talking about behavior. So this means when you start with a use case, you would typically start with use case slice. So use case may have lots and lots of behavior, but you start from, I guess, essential behavior and then behavior on top. So let's say we figured that one out. And as we're trying to implement the most essential behavior, such as the behavior that when we try to withdraw funds, that the balance will be reduced by that amount. So our use case is withdraw funds. Then when we're writing that unit tests, immediately our unit test needs to target something. And in case of hexagonal architecture, it will target the driving port. That will immediately force us to think about what are the inputs and outputs. So the test will force us to think about it. So in the case of withdrawing funds, we then come to the conclusion that when withdrawing in the request itself, we want to pass in, which account number and what's the withdraw amount. And then we need to assert something. And then we're thinking, okay, what are we asserting? Well, we need to assert, let's say using the stateful approach, that now the account balance has been reduced. So we figure out we need to retrieve an object from storage, after this use case was executed. And after we retrieve the bank account, we want to assert that the balance is the reduced amount. So notice in this sentence when I said we need to assert, after we retrieve from some persistence mechanism, this is now forcing us to define the driven ports. And what happens is now, essentially, in the process of writing this unit test, the only thing that this unit test is now aware of is the driving port for exposing this use case and the driven ports that are needed for this use case to work. But there's nothing about use case implementation here at all. And what happens is that then that test will fail because our use case is not yet implemented. And then it will essentially force us to implement the use case. So that's one aspect that is going to happen. And the other aspect that will also happen is with regard to driven ports, that as we're writing this unit test, we will be forced to substitute some test doubles for the driven ports. Now, indeed, I must say that this question is a very good question, and it also relates to, just as a side point, some initiatives I'm planning in the future. I'm currently working on a book regarding testable architecture, hexagonal architecture. Later, also want to cover clean architecture. And after all of that is covered, I would also like to illustrate TDD with it. So the answer that I gave during the past several minutes is a very short answer. But this is actually a whole topic in itself. Feel free to ask any sub questions or something, but this is I guess the simplest answer that I could give for now.
So I think Tech Cafe has something exclusive here that you are going to publish a book, huh? So yeah, it's great news, and we will be looking forward towards that. Very excited to know you're in the process of writing a book. That's great. There was one question, but it didn't come up on StreamYard, so I posted it back. So the question goes how to implement this in existing code. I think that if we're going to translate the question, our colleague that posted it is talking about legacy code, probably.
Yeah.
I know this is a very, very big topic.
It is.
I'd like to hear your answer regarding that.
So the short answer is it will require a whole heap of prerequisites regarding testable architecture before we can even attempt essentially TDD. So what happens is, first of all, most legacy projects, they are untestable. So examples include you have code in your service or in your services or use case handlers, and it is, let's say, directly using a HTTP client to connect to PayPal. That immediately makes the code non-unit testable. Or it is directly executing like SQL queries, or using ORMs, and then you have to use a very specific database to run the tests. All of that makes the code non-unit testable. Now, here's the problem regarding trying to do, let's say, tests with that. So that immediately fails the first essential condition regarding hexagonal architecture, that we are able to abstract away any secondary actors. So here, if we have direct coupling to the database or file or external systems, it immediately means you are not able to write the tests in the kind of way prescribed by hexagonal architecture. So you can't have unit tests for your use case. So it's like immediately failing at that point. That consequently means it's also failing then immediately clean architecture as well. And we're also failing ability to do TDD, because if something is not unit testable, and majority of TDD is about writing unit tests in a TDD way, well, we're failing there. So the very first step for legacy code is to attempt to transition it to hexagonal architecture like code. So this means, as a rough overview of steps, because this is a very common question that I get asked, is roughly look at your code in terms of presentation part, then your application or domain part, and finally the infrastructure part. So your presentation part might be, if you're a backend developer, your REST API. So your first step is, please check that any logic that you have in the REST API, for example, if, else statements, calculations, calling the database, cut and paste that code outside of the REST API. Whether you have application services or command handlers, whatever you have, just remove it from the REST API. Then when you have these application services or use case handlers, look at cases where they are directly communicating with I/O. So directly talking to PayPal, directly talking to a database. Cut and paste that code somewhere else and introduce interfaces in between. That is what I see as essentially the minimum to get into hexagonal architecture. When you have that, you can then retroactively write, when you have hexagonal architecture in this minimal way, you can then retroactively write unit tests by targeting the driving ports that you now have and using test doubles for the driven ports. And then when you have this testability, then you can proceed for new functionality for this use case to implement it in a TDD-like way. So again, this is a huge topic, and one that is also something within the scope of the books that I'm planning to publish. And this also happens to be also a key focus in the kind of technical coaching that I do, whereby before getting to TDD, we spend a lot of time transforming the existing legacy code into hexagonal architecture. It is definitely painful, really, really painful.
I'd like to add something to your answer, Valentina, that Michael Feathers, in his famous book, Working Effectively with Legacy Code, has introduced something called the legacy code change algorithm, okay, which basically follows 5 steps. Those are identify change points, find test points, break dependencies, write tests, then make changes and refactor. Okay, in Michael Feathers' definition of legacy code is that it's code without tests. Okay, of course we can think of many other definitions. That may be code without structure as well, or code that is hard to change or hard to understand. Okay, And this is the kind of code that you get when you don't do TDD and when you ignore the refactor part in TDD. Okay, so you will get code without proper structure that makes it both testable and maintainable and extensible. So I will refer people to Michael Feather's book as well until Valentina publishes her own, and they can follow Michael Feather's recipe, the legacy code change algorithm, which is basically identify the points that you want to change in the code, find the point where you're going to test the point or the points you're going to change, break the dependencies, because this is the biggest problem with legacy code. It's the embedded dependencies, and working effectively with legacy code is all about breaking dependencies, okay? Then you write the tests, and then you make changes and refactor. Kent Beck has a famous quote, which he said recently, and that is, make the changes easy, then make the easy changes. And I think that this quote is a very, very short summary of Michael Feather's recipe, is that sometimes you have to do a little bit of refactoring before you start writing the tests, okay? And I do recall that in a previous session, which you've presented, Valentina, you actually had your own algorithm for working with legacy code or introducing TDD into legacy code. So maybe we can do that again with Tech Cafe. Let's have a dedicated session for that in the future.
Okay. Yeah, so that was the whole session in itself. And I also want to link some of this discussion again regarding Michael Feathers. So regarding the transition, about identifying the change points and breaking the dependencies. That's a really essential point if we're talking about hexagonal architecture. It is to break the dependencies. So for example, we are breaking the dependency from our domain, like which has business logic. We don't want to have direct dependencies to database or PayPal. We are breaking the dependencies by introducing the interfaces. And that point about breaking that direct dependency with introduction of interfaces is then what enables us to then, as the next step, write the tests, because we can use test doubles for those interfaces.
Okay, let's take another question by Amani Isa. It goes as follows. How is dependency injection or inversion of control implemented in hexagonal architecture?
Mm-hmm. So we can essentially look at dependency injection in the most visible form in the driven ports. So as we know, we have certain interfaces for the driven ports. For example, bank account, repository or something for storing bank accounts, or customer gateway for communicating with an external system which provides us information about customers, or payment gateway for communicating with some payment provider. So we have those interfaces, and when we write the internals of Hexagon, we are depending on interfaces. Now we know at some point, well, we have to hit the real thing. Mm-hmm. That happens at runtime. So at runtime, for each of those driven ports, we need to substitute the actual real implementation. So that's where we are substituting the adapter. So during real execution of the program, we you might set up your IOC container that you would say, let's say for bank account repository interface, that the MongoDB bank account adapter will be used, and that's your class where you're communicating with MongoDB. Or for your customer gateway interface that you will be using, again, you specify your adapter, your real adapter class, which is talking to some third-party system REST API. So essentially in your IOC container, you set up dependency, for those driven port interfaces, what will be the adapter implementations. And then that means during real execution of your system, those real adapters will end up being executed. But for the unit tests, in that one, you are essentially just for each driven port interface, you are instantiating some kind of test double, and then that means that test double test fake implementations are essentially getting injected. So I would say that that's essentially the key point regarding usage of dependency injection on the driven side, and that's the one that's, I would say, easier also to understand. But there is also dependency injection happening on the driving side as well. So if you're modeling your driving ports as some kind of interfaces, and your presentation layer, e.g. your REST API, is calling driving port interfaces. Again, in your IOC container, you will need to specify that for the driving port interfaces, what are the concrete implementation classes. So this means we have it on both sides. Now, I must also say there was a bit of controversy in recent times regarding the usage of word inversion of control. Alistair Cockburn wrote a whole long article why he does not, even though many people, they are using inversion of control word, as was raised in this question and have been for the past several years when they speak of hexagonal architecture, I have done as well. But he actually wrote a whole long article about where you may discover why he no longer uses that word anymore. So that was just a side point, but the essence of this concept that I explained remains the same.
Yeah, so thank you very much for mentioning that IOC and dependency injection are actually two different things. And yeah, Cockburn did write a paper about that, and he was very critical about the Wikipedia article discussing both concepts. Many people consider dependency injection to be a branch of inversion of control, when in fact they are totally different concepts. So yeah, I do recommend that people read that paper in order to be able to differentiate between both concepts. And I think in the context of domain-centric architectures, people are mainly talking about the use of dependency injection, and I think that was mainly discussed in clean architecture.
Yes. Now, I do want to say, from practical perspective, if you look at, let's say, the kind of implementations that I'm doing and that you'll find many on the internet, we are using dependency injection. So that's like not the only way, but that happens to be just the most common way, let's say, that we can achieve the implementation.
Yep. Okay, so I think we can take one last question, and that's actually my question this time. So we discussed writing unit tests, and I think people will write integration tests and API tests as well. But there is a little bit of debate about writing tests at the level of the front end, okay? So do you recommending writing tests at the level of the front end?
Okay, so first of all, I guess I'll answer what could be done, and then the other part, whether something should be done. So what could be done? In the same way that someone can apply hexagonal architecture in the back end, and if you look at the internet, I mean, most examples of it are on the back end. Similar approach could be used on the front end as well. So we could say on the front end part, you could have also pure, whether you have classes or functions or whatever you have representing the use cases. And that is independent of, I mean, whether you're using React or Angular or whatever else, just pure code. And then your driving adapter could be the kind of code which is, let's say, the actual UI presentation, such as the actual UI components on the screen. So you could think of it in that way. And on the outgoing side, we could say your driven ports could abstract away your communication with the backend. And then you could have driven adapters which contain actual code for communicating with the backend. So that is essentially how you can use a hexagonal architecture on the front end. Now I'm going to speak to answer, I guess, my personal perspective. From what I've done was basically using hexagonal architecture on the back end. That's where I coached teams. I do know that people are also using hexagonal architecture on the front end as well. So I would recommend, looking at that, trialing it out and seeing if it works, if it's suitable for your project. What happens is immediately if you choose to use hexagonal architecture, then yes, alongside with that, you will have tests targeting the driver ports. There's one more additional thing that I want to say regarding test types. Hexagonal architecture only talks about the tests which are targeting the driving ports, i.e. testing the hexagon. It does not at all address the points of testing the adapters. And I want to just add along the book topic as well, since that part was unaddressed, I will be addressing that in the book as well. So it's yet a big, wider topic. So thanks for raising this.
Okay, so I think time's up. Thank you very much, Valentina, for this great session and for your answers to the questions. I think the answers were as useful as the session. So thank you very much for that. And we look forward to hosting you in coming sessions with Tech Cafe. Valentina has her own podcast, the Technical Excellence podcast. So you might want to tune into that as well. They host great people and they host great sessions. So thank you very much, Valentina, for being with us today. And follow us on LinkedIn by simply accessing our website, techcafe.com. You can follow us on different social networks and view our previous sessions on the podcast. Again, I would like to thank our sponsor, Cegedim Egypt, for making today's episode possible. And please follow Cegedim Egypt. They have great offerings, especially in the healthcare industry. So follow their LinkedIn page by simply scanning the QR. To our dear audience, thank you very much. And to Valentina, thank you again for coming, and hope to see you guys in a coming episode. Thank you so much.
Thank you. I really enjoyed this session today, and want to say thanks a lot to the audience. I really enjoyed this discussion and these comments. So these are big topics, and I do plan to zoom in more into those in the future in writings, and who knows, hopefully we see each other again.
Yeah, I hope so too. Thank you very much.
Thank you.
Thank you. Bye-bye.
Bye.